In lesson 6.6, we are going to be talking about the properties of kites and trapezoids. So we just finished up talking about rectangles, rhombus, and squares, and we talked about all of their properties and how we could prove that something was them. These are two more special quadrilaterals that we're going to talk about today. I want you to pause the video and complete the 4 warm-up problems, show your work on your note guide, and write down your target. When you're done, press play to see the answers. So make sure you have the work on your notes for your warm-up. Make sure you check your answers. For number 1, you should have 2 answers since it's a quadratic equation. You could use the quadratic formula, or you could try to factor it. This one would be good solving by square rooting because there's no just x term. So a kite's definition is that it is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So there are 2 sides that are congruent to each other, and they are right next to each other. And then another 2 sides are congruent to each other, and they are right next to each other. And we have some properties about kites. We know that if a quadrilateral is a kite, then its diagonals are perpendicular. We also know that if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. So make sure you fill in those theorem shortcut names. Remember, these are the names of your theorems. So when you want to use them or justify something, you can write this abbreviation. That is how I want to see it written. It's in the if-then format, like a conditional statement. So let's apply some of these. All right, so Lucy is framing a kite with wooden dowels. She uses 2 dowels that measure 18 centimeters and 1 dowel that measures 30 centimeters and 2 dowels that measure 27 centimeters. To complete the kite, she needs a dowel to place along KL. She has a dowel that is 36 centimeters long. About how much wood would she have left over after cutting this? So we want to know how long this is. We want to know if that is underneath 36, and it sounds like it is going to be, so how much would she have left? All right, well, since we know it's a kite, do we know it's a kite? Yeah, look, we've got 2 pairs of consecutive congruent sides. So we know it's a kite. Therefore, the diagonals are perpendicular. We also know that 1 pair of opposite angles are congruent. That might help us. This angle here and this angle here would be congruent to each other. All right, so starting off, I'd be looking at those triangles, and we know that these lengths would be congruent to each other as well. Do you remember why, or can you think about what theorem justifies that? Well, like we talked about with rhombus, when we were talking about a rhombus and we were doing proof, K is equidistant from J and M. And since K is equidistant from J and M, what can you say about K? K must be on the perpendicular bisector of JM. Remember that theorem? So because of that, then any point on this line would be equidistant. So this point here in the middle, if I wanted to name it, I could name that X. X is going to be equidistant from J and M, which means I know those are congruent to each other. Excellent. So we know that those 2 little right triangles are congruent to each other. You think about it, you've got a leg, you've got a hypotenuse. They're definitely going to be congruent. Now I could solve this because I could find what this length is. How could I find that length? Well, since the whole dowel measures 30, we know this is 15, right? No work there. Now I can find the top part and the bottom part using what? Using the Pythagorean theorem. So I'm going to have 18 squared equals 15 squared plus kx squared, the length of kx, and I'm also going to have that 15 squared plus xl squared equals 27 squared. So take a minute, solve that, finish the problem, pause it, and then press play to see the answer. Okay, so hopefully you finished the work for this problem. Now you're checking your answer with mine, please. Let me drag that out of the way. So you can see that I found my 2 lengths, then I added them together to get the whole length of KL, And now that I have the entire length of KL, I can subtract that from 36 to make sure I see how much I have left. So I would have about 3.6 centimeters left over. All right, moving on to example 2. I'm given that this is a kite. In kite ABCD, I'm given that the measure of angle DAB, so let's mark it on the picture, DAB, this whole angle is 54 degrees. I'm also given that CDF, this part, is 52 degrees. I want to find 3 angles. So I like to mark them so that I know what I'm looking for. I want to find BCD, so this whole angle here. I also want to find ABC, this whole angle right here. I also want to find FDA, so this part right here. So pause the video, try it, think about what theorems you're using to find each angle, and then press play to go over the answers, and we'll talk through them. Okay, so let me walk you through my thought process. Since it's a kite, I know that these sides are congruent to each other and these sides are congruent to each other. All right, so when I'm trying to figure out the first one, the yellow angle, I'd be looking at what shape I have created. See, this is a right triangle. I'm sorry, this is an isosceles triangle now, right? So what do we know about our isosceles triangles? Well, since it's a triangle, we know that all 3 angles add up to 180. And since it's isosceles, we know that the base angles are congruent, which means this one is also 52. So how can I find this angle over here? I can do 180 minus 52 times 2. For the measure of angle ABC. So for the middle one, when I look, I'm trying to find the measure of ABC. Well, if I have an isosceles triangle on the top half of the kite, I obviously have an isosceles triangle on the bottom half. So really, I would solve for the blue angle first. If this is 54, I know this angle will be 180 minus 54 divided by 2. Now that I know that this is 63, I know that this is 63. So how did I get the measure of angle ABC? I added those 2 together and got 115. If you have any questions, we can go over this. Obviously not in the video, but on another day. All right, excellent. So what is a trapezoid? A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. The base is each of the parallel sides. The legs then are the non-parallel sides. And the base angles are 2 consecutive angles whose common side is a base. So sometimes we like to skip over the vocabulary, but you need to know what I'm talking about if I say base versus leg here. So make sure you know the difference. The legs are the non-parallel ones. The bases are always the parallel ones. If a trapezoid is an isosceles trapezoid, then the legs are going to be what to each other? They're going to be congruent. So make sure you read over those definitions. We also have these theorems now about trapezoids. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. If a trapezoid has 1 pair of congruent base angles, then the trapezoid is isosceles. A trapezoid is isosceles if and only if its diagonals are congruent to each other. Pay attention to the abbreviations so you know how to use them. Also, I would take time to think about how to prove each of these. Practicing writing 2-column proofs for theorems is a great way to improve your knowledge. All right, so try example 3, please, showing work and thinking about what you're using, and example 4. Then press play, and I will go over that. I'll actually try example 3, 4, and 5. So try this whole page, applying what you just learned, and then I will go over them after you unpause the video. Okay, so let's talk through these. In both of these pictures here, I'm given isosceles trapezoids. Make sure you see the markings. You've got one pair of parallel sides, and then the other non-parallel sides are congruent to each other. So it's an isosceles trapezoid. So I know the base angles are congruent, and I know that this is a quadrilateral, so all the angles add up to 360. That's how I can get that the measure of angle A is 80 degrees. For the second one, if it's an isosceles trapezoid, I know that the diagonals are congruent to each other. So if this whole diagonal is 32.7, this piece is 21.9. If I wanted to prove it, I could show the segment addition postulate and substitute it in. But I know this is going to come out to be that the length of FB is just 10.8 meters. There might have been a little confusion on this M. I meant that as meters, not as a variable. Next one, if again we are given a trapezoid, okay, and in the picture you don't see that it's isosceles, but they tell you that it's isosceles. So again, the base angles are the same; they are congruent to each other. So we can set them equal. Solve. A can be a positive and negative number because it doesn't come out to be a negative value for the measure of the angle, right? So A can be -9. When you plug it back in, it's still going to come out as a positive measure for that angle. In example 5, again, you're given that it's isosceles, the diagonals are congruent to each other, so you should get x equals 3. All right, so last piece then, trapezoid midsegments. Trapezoid midsegments are segments whose endpoints are the midpoints of the legs. So just like we had midsegments of triangles, we can have midsegments of trapezoids. And notice the theorem. The length of the midsegment is always going to be 1/2 the sum of the bases. We also know that the midsegment will always be parallel to the other to the bases of the trapezoid. So you can apply this in example 6. Pause, solve 6, then press play to go over it. So the length of EF is going to be 1/2 the length of the bases added together. When I add these together, I get 21.5. If I take half of 21 and 5/10, I will get that the length of EF is 10.75 units. Hopefully this video helps you to understand the lesson and complete your notes.